Today we are going to look at our introduction to saponification value, and basically we are going to talk about the reflux condenser, which happens to be an important glassware which is used in the determination of saponification value of lipid. We'll start our introduction by looking at what the reflux condenser is. So, the reflux condenser is a laboratory glassware that cools vapor and condenses it back into liquid without loss to enable a continuous reaction. And this is a picture of the reflux condenser. Description of the reflux condenser. So first of all, what we have to note is that the reflux condenser is a laboratory glassware with a water inlet at the bottom and water outlet at the top. So as seen over, this is the water inlet at the bottom and this is the water outlet at the top. Inside the reflux condenser is an outer surface area that allows the flow of water through it and out. And again, inside the condenser is also an inner condenser, which is either coiled as seen over here. So this is a coiled inner condenser straight, and this is a straight inner condenser or spiraled, and this is a spiraled inner condenser. And this is where heated vapors emit in reaction changes their state back to liquids. The inner condenser is basically connected to the mouth of the condenser, which is fixed into the round bottom flask containing the test reaction. So this is the inner condenser of the reflux condenser, which is being connected to the mouth of the reflux condenser and fixed into the round bottom flask. And from this picture, this is our reflux condenser over here being fixed into a round bottom flask over here. And this is the water inlet of the reflux condenser, and this is the water outlet, which is at the top of the reflux condenser. So, and this is the condenser. So the part of the condenser which is colored blue is the outer surface area of the condenser, and the part which is colored ash or gray is the inner condenser, and this is the part of the reflux condenser where the heated vapor emits during reaction changes its state into liquid. And what you also have to notice is that when water enters the reflux condenser through the water inlet, it first occupies the outer surface area of the condenser to cool the heated vapor in the inner condenser that the heated reaction emits. The water then flows out through the water outlet as shown over here to allow continuous flow of cool water into the condenser through the water inlet at the bottom here. The cooling of the heated vapor changes their state back to liquid by means of the straight or spiral or coiled circulating cooling system of the inner condenser. So this is just a description of the reflux condenser. Saponification test setup. So the picture over here shows a simple setup for determination of the saponification value of a lipid. So this is our heating mantle, and in place of the heating mantle, we can also use a boiling water bath. So this is our round bottom flask containing our reactants, and this is our reflux condenser being plugged into the round bottom flask over here, and this is the water inlet and water outlet, and this is the condenser which consists of the outer surface area and the inner condenser. So we are going to pick the parts and look at their importance. So the first is the round bottom flask. This is the reaction vessel where the reaction mixture is placed. And also it has a round bottom shape to promote even heating and efficient mixing. The next is the heating mantle. So this is the heating mantle over there. It heats the flask so the reaction mixture can stay at the right temperature. The condenser. It cools and condenses any vapor produced during the reaction. It also prevents the vapors from escaping into the environment and ensures they return to the reaction flask. And this, as a result, maintains the reaction volume throughout the experiment. And we also have to note that the condenser is designed with the water inlet at the bottom and the water outlet at the top. And this design allows for efficient heat transfer and ensures that the hottest air is removed from the top, so while cooler water continues to enter from the bottom to maximize the cooling effect. Let's look at how cooling effect is obtained in the reflux condenser. So what you have to notice that as cold water enters the condenser from the bottle, that is the water inlet, it fills the outer surface, and this is the outer surface area of the condenser, the part labeled green over here. So it fills the outer surface area of the condenser completely and flows through it to absorb heat from the vapor or gas introduced into the inner condenser, and this is the inner condenser during heating. And this, as a result, heats the water, and as the water heats up, it becomes less dense and rises through the condenser to exit from the top, so which is the water outlet of the condenser. And as this happens, there is a continuous flow of cold water through the water inlet into the condenser to maximize the cooling effect. So in brief, this is how the cooling effect is obtained in a reflux condenser. Importance of reflux condenser in chemical reaction. So first of all, what you have to notice that the reflux condenser is a technique used in chemistry to one, enhance the efficiency of reaction, and two, to prevent the loss of volatile reactant, and three, to facilitate the formation of desired products by maintaining optimal reaction conditions. So let's pick them one after the other and look at them. So the first is the enhancing reaction efficiency through controlled heating. What we have to note is that the reflux condenser is important for heating chemical reaction, as it allows the mixture to hit boiling point and condenses the vapor back into the container. And this helps keep the reactant at high temperatures, making the reaction happen faster and more efficiency. The next is preventing loss of volatile reactant during reaction. During certain chemical reactions, volatile compounds may evaporate and escape from the reaction vessel if not properly contained. A reflux condenser effectively traps these volatile substances within the apparatus by allowing them to condense back into the reaction. So as we can see, so these are the condensed heated vapor from the reaction, which is being trapped back into the reaction in the round bottom flask over here. And as this happens, this prevents any loss of valuable reactive component and ensures that all reactants participate fully in the intended chemical transformation. Formation of desired products by maintaining optimum reaction conditions. Reflux condenser helps to maintain optimal conditions for chemical reactions, thereby facilitating the formation of desired products. By providing a constant source of heat and preventing evaporation, it creates an environment where reactions can proceed at their most favorable temperatures and concentrations. And this controlled environment allows for better and desired product formation and yield. Thank you.